A massive iceberg nearly the size of Hobart has broken off from Antarctica. Aerial footage shows a huge crack in the 150-metre thick ice shelf, creating an almost 1,300 square kilometre iceberg. Dr Ben Galton-Fenzi is a glaciologist and ice ocean modeller with the Australian Antarctic Division, and he joins us now from Hobart. Ben, welcome. So take us through what's happened down in Antarctica over the last couple of days.
Yeah, thanks, Joe. Well, what's happened is that there's been another great big iceberg that's carved off from the ice sheet, as we've heard. It's from an area called the Brunt Ice Shelf. It's on the exact opposite side of Antarctica from where the Australian Antarctic Territory is. It's in the Weddell Sea area. It's been an iceberg that scientists, particularly at the British Antarctic Survey, have been monitoring for some time, probably over about the last decade, and it's just carved off within the last couple of days.
Yeah, and we're just seeing some really dramatic shots of the crack. Can you tell us how long that line is? Like we've heard, it's about 1,300 square kilometres, a whole piece. But is that just to give people a better idea? How long is that crack that runs across Antarctica?
Well, it's an ice shelf on Antarctica. So these big slabs of ice form when snow kind of accretes on top of the continent, and over hundreds of thousands of years they flow out towards the ocean, and then they meet the ocean and they want to start to float because they're thin enough, and they form these huge expanses of ice that are actually over the top of the ocean. These cracks can be, tens and tens of kilometres long, actually, and this particular one is massive. Yeah.
And you say when the snow becomes thin enough, it's still kind of 150 metres thick, huh?
Yeah, there's areas of ice in contact with the ocean in East Antarctica, for example, that's in the Australian Antarctic Territory, that's 2.5 kilometres thick in contact with the ocean. Oh, right. So this sounds massive. It is massive. It's a significant calving event. These types of calving events don't happen very often in our lifetime, so it's a really interesting thing to monitor. The more we can learn about this, the more it's going to help us be able to predict how the future of the ice sheet will respond to climate and other perturbations in the climate system.
So is this effectively drifting away from Antarctica now? Do we call it the Brunt ice shelf? Is it drifting away from Antarctica?
Yeah, it'll be given a name, actually. It'll be iceberg, and then it will have a sort of a letter and some numbers after that.
Maybe the Ben Galton-Fenzi iceberg.
If I'm the one that discovered it, no, it gets given there's an international naming convention for where icebergs come from around the continent, and then they're tracked over time, actually. And the process of understanding where it's going to go, it's as uncertain as understanding exactly when the iceberg's going to carve. There's a lot of uncertainty there, so it could reground. Or it could keep floating off into the Southern Ocean, and it might even make its way up around South America, for example.
Wow, okay. And so are you monitoring it closely enough to tell us how far it's moved away from the continent by now? Is it still kind of attached, or it's like 100 metres off?
Yeah, it's definitely detached from the continent now. It is an iceberg by itself, and we say that it's carved. So if we think about all the snow that falls on the continent, about half of it melts off the underside of those ice shelves, and then the other half is from this process of iceberg carving. And there's a range of sizes that occurs over. There's lots of little icebergs that get carved every day. These big ones that get carved happen every so often, and they're very interesting. We can monitor how they move in the ocean. They're going to start to melt, and it'll start to disintegrate as well. It's interesting for a lot of different reasons. One of them is because the uncertainty that's built into the climate models around how icebergs carve and how the ice sheet loses mass through icebergs carving is very uncertain. So the more we can understand these processes and watch them, the better we can make the models to improve the predictability of the climate system. But the other thing that's going to happen here is when the iceberg moves away, it's going to expose a patch of the ocean that's probably never had exposure to light in the atmosphere for perhaps thousands of years. And so watching the sort of colonisation process of new ecosystems as they move into that area will be incredibly interesting. And then the iceberg itself, when it's moving away, it's melting and it's releasing fresh water into the environment, but it may even impact with the bedrock, in the bottom of the seabed. And if it does that, it's going to scour off sort of large swaths of bottom ecosystems as well. And that's a process that happens all the time.
All right. And so, yeah, you mentioned light, and that's really interesting, light, some portions of the Antarctic seabed being exposed to light for the first time. Can you tell us what the depth of the sea is, what it would be underneath that ice shelf that's just broken off? Would it only be a couple of metres, or would there be hundreds of metres of water underneath that?
I don't know for sure. I imagine the scientists that are at Halley Research Station know pretty well what it is. The way that we understand how deep the water is that we get on the ice, and I've done this myself, we set off explosives, and the time it takes for the sound to travel down through the ice and then through the water column and reflect back up to the surface, we can measure, and then that tells us, because we know the propagation speed of sound in ice and seawater, tells us how deep it is. But it's likely probably a couple of 100 metres deep, I'd say, under the ice at least, but it could be even deeper, maybe several hundred metres.
Yeah. And have you been involved in the study or seen any work done on the studies of when this has happened before, when those ecosystems are exposed to life that are sometimes hundreds of metres deep?
I've been involved in some studies on the Amory ice shelf in East Antarctica. That's the one that I mentioned that has a ice that's in contact with seawater that it's 2.5 kilometres thick. We've actually seen evidence for life underneath the Amory a couple of 100 kilometres away from the ice front through holes that were drilled through the ice and images, cameras that were deployed down through it as well. And so we know that the ocean does circulate in and out of these areas. I haven't been involved in any studies that have looked at the impacts of iceberg carving on ecosystems, for example, but I know that it does happen, and there has been a particular focus on the peninsula, particularly with the collapse of the Larsen ice shelves, to try to monitor those ecosystems.
Yeah, it'd be really interesting work. And you mentioned Halley Station there. And you, a bit of a smile on your face there, I might just explain to viewers, because that's very close to where this is carved. It
is close. They moved the station about 4 years ago, I think it was, because of concerns around the speed of propagation of the rifts around the area. And I understand now that there's no scientists there currently because of those similar types of concerns. So I imagine there's probably a bit of a nail-biting moment when it did carve, but it's one of those things that the iceberg that did carve, it was carved because of the propagation of these very big rifts and crevasses that had formed. And once those things start to appear, it's fairly predictable. The exact timing of it, though, is not. And when those rifts do form, it's not as well known either. But for this particular iceberg, they've been expecting this one to come, and it has. And so in one way, that's probably, there's a sense of relief there that it has actually occurred, and they can now kind of get on with monitoring the other rifts in the area. Yeah,
and Halley Station has survived it for now. So is there any way of predicting how long it's likely this iceberg will remain intact?
Yeah, it depends on where it goes. You know, if it's going to stick fast on the seabed nearby, the oceans around Antarctica stay very cold, and so it's not going to melt very fast at all. But if it does kind of move offshore into the deeper ocean and gets circulated in the Australian circum-Antarctic current, for example, then it may move into much warmer waters, in which case it will start to disintegrate much more rapidly. So time will tell. It's one of those things that's very hard to predict exactly where it's going to go.
And how big is this compared to other recent carvings?
It's a big one. Yeah, like you said, I think it's roughly 1,200 square kilometres. Yeah. In September 2019, the Amory ice shelf, which I've just talked about a couple of times already, it carved an iceberg from an area we called the loose tooth, because it looked a little bit like a wobbly tooth from space. That one was 1,600 square kilometres. That one was also incredibly big. The icebergs of this size don't come along that often, and that's why it's very interesting to watch what this will do. It's a big tabular iceberg, we would call it.
Yeah. And is this part of a regular natural carving process for parts of Antarctica, or is it happening more often now than it has before?
We can't say for this particular iceberg, for any one particular iceberg, because, like I said, the predictability of them is so difficult. I mean, you've got to think about iceberg carving as kind of being like earthquakes, in the sense that we know there's something that's going to happen, but the exact timing of it and how it exactly happens is very uncertain. And so for this particular iceberg, it's part of the natural variability, I'd say. Big ones happen less often than little ones. Little ones happen more often. and there's a size range of icebergs that are being carved from Antarctica all the time. We do expect, though, that under future warming, future climate change, that the rate of iceberg carving will increase, and that's due to a range of factors through ocean-driven melting at the bottom of them and increased surface melting on the surfaces, driving more of that crevassing and the rifting and carving processes.
But there's no evidence that that is happening already at a greater rate?
No, statistically, we don't have enough observations, not for these types of large icebergs anyway, to say definitively that this thing is happening more due to climate change than natural variability. It's not something that we can make a statement about.
Yeah. And what is the evidence more broadly about the impact of climate change on Antarctica?
Well, we know the ice sheet is changing due to warmer ocean waters. There's areas of the West Antarctic ice sheet and areas within East Antarctica as well. The Totten Glacier is one that we have been monitoring. That does show a surface lowering, and we think that that's due to increased ocean melting of those fringing ice shelves. And that changes the driving stresses, we would say. So the ice wants to flow faster out towards the coast, and it causes the inland ice to draw down, and that's what's contributing to some of the sea level rise that we are measuring today.
Yeah. Okay, Ben, really interesting having a chat to you. When are you going to next get down to Antarctica?
We have plans underway. We're waiting for our new icebreaker, Nurinia, to come online and finish all its sea trials that it has to do, and then we'd like to head to the Denman Glacier. We've got a new funding initiative starting up to support that activity, but that's probably not going to be for a couple of years, unfortunately. But there's a lot of work to do in the meantime.
Good. Okay. Great talking to someone with your such apparent enthusiasm for your area of expertise, and good luck for your next trip down there.
Thanks very much. Thanks for having me.